In order to simplify this expression, we need to factor top and bottom. So we're going to factor the top to start with. Let's do that. I need a big X I multiply 3 and 15, and I get 45. And on the bottom, I put the 14. And I have to think of, two numbers that multiply to get 45 and add to get 14. Well, I know 3 and 15 because that's what's given. I came with 3 and 15, but those don't get 14. All right, what's another configuration? Well, 9 and 5. How about 9 and 5? Does 9 and 5? Yes. So 9 and 5 work. All right. So what I'm going to do for the top is I keep the 3 in squared, and I keep the 15 here. And what I'm going to do is I have a plus 9 in plus 5 in. And what I did there is I changed 14 using this factoring technique into a 9 and 5. Okay, I kept the front and back. I just changed the middle, the two terms. And then I'm going to do grouping. All right, so the grouping here, I'm going to group these two. I pull out a 3 in out of the first piece, which would leave us with n plus 3. And the second piece, I pull a 5 out, what also leaves us with n plus 3, which that's what it should. Okay, because these should always match. So factored form would be n plus 3 times the remainders right here, which is 3n plus 5. So that would be the numerator. All right, so the denominator, though, what would be the denominator? Well, let's see. We'd have these two pieces multiplied. That's 18. All right, the bottom would be 9. Okay, think of two numbers that multiply to do that. Well, we know we have 2 times 9, but that's not going to work. So how about 6 times 3? Yeah, 6 and 3 work. Okay, with that said, so now we keep the bottom as 2n squared, and at the end over here we put plus 9. And the middle, which was a 9n, we're going to write as 6n and a 3n. Okay, now we're going to pull out some GCFs, use grouping. So I'm going to pull a 2n out of the first piece and a 3 out of the second piece. When I do that, 2n times n and 2n times 3 gives the first piece. And this would also be 3 times n is 3n, and 3 times 3 is 9. So these match like they should. So we have n plus 3. And then these two pieces are left over, so we have a 2n plus 3. Now all of that leaves us for the top n plus 3 and a 3n plus 5. And on the bottom, we have an n plus 3 and a 2n plus 3. Do either the top and bottom have anything exactly the same? And yes, they do. They have factors that are the same. That creates a 1, because anything over itself is a 1. 1 times anything kind of just doesn't change its value. So what's left is a 3n plus 5 over 2n plus 3. And that would be our simplified form. For this problem here, we want to state the restriction of this. The restrictions are when the denominator equals 0. So what makes this denominator, we ignore the top, equal 0. So we got to factor it to see that. And if we're going to factor this denominator, what we're going to do is we're going to pull out a 6, because they both have a 6 in common, and they both also have an r in common. All right? So we're going to factor it. And again, we're trying to find out when the denominator equals 0 is what we're looking for. All right? When we pull a 6r out, that leaves you r. When we pull a 6r out of 6r, that leaves you a 1. So we have positive there. All right, so to find the restrictions, well, we set each factor, this is a factor and so is this, equal to 0, because either of these could be 0. So when we set each factor equal to 0, we have 6r equal to 0, and we have r plus 1 equals 0, and we solve it. So this one you divide by 6. So 0 divided by 6 is 0, so 0 would cause a 0 in the denominator. And you minus the 1 over, and you also have r equals negative 1, would also cause a 0 in the denominator. So both these are restrictions. I should probably say that r cannot equal each of these, because those values are restricted. If you plugged either of these into this, you would get an undefined result. in order to solve this, we want to multiply by the lowest common denominator, if we can figure it out. But since it's hard sometimes to do that, let's just multiply by the biggest thing each time. So looking at this, I have a 4, a 2, and an x. I know 2 is small numbers, so either I multiply by the 4 or the x. I'm going to start with multiplying by the 4. So what's going to happen here is I'm going to multiply both sides, which is each piece, by 4. Okay? All right, so multiplying each piece by 4. So when I do that, the 4's cross out here, leaving you 5, equals. The 4 and the 2 reduce to a 2, so you have a 2 times 1 left. And lastly, you have a plus 4 over x. So now, the only denominator left is an x. So next, I multiply everything by whatever's left, the x. So let's do the x. So in order to do that, I'm going to multiply this by x. I'm going to multiply this by x, and I'm going to multiply this by x, which is both sides. When I do that, I get a 5x equals, this would be a 2x, and the x's would divide out, leaving you just simply 4. And now I'm going to solve for x. So I'm going to minus the 2x to both sides. That would leave you 3x equals 4. And then I divide both sides by 3. 3's disappear, so we get x equals 4 over 3, and that is my answer. Now I look at the denominators. Will 4 over 3 cause this denominator, which is only x, to equal 0? No. So this answer is okay, because the restriction would be 0, but that's not a 0. So this one, in order to do this one, to solve this one, we need to multiply by the lowest common denominator, or just a denominator. And so I look at all three of these. This one looks like it has the most, but I'm going to actually pull a GCF out of this just to see something, because it's kind of important to factor the denominators before you kind of get started here. So in order to do that, I'm going to pull out an x, leaving the UA 3x plus 4. So this, I'm going to cross that out. That's the new denominator for the first one. Then I have this one, no GCF, nothing to factor there, no factoring there. So out of these three denominators, this has the most. So I'm going to multiply all pieces, or both sides, by that lowest common denominator. So the first one's going to be x times 3x plus 4. That's the first one. This one's going to be times x times 3x plus 4. And the last one we're also going to multiply by x times 3x plus 4. So again, I chose the one with the most, and that was the first one. Now what you'll notice here is this whole thing will cross off with that whole thing, leaving you just the x plus 1 left. For the next, this piece will cross out with this piece, leaving you 1 times x, which is x. And here, the x will cross out with the x, leaving you a minus 1 times 3x plus 4. All right, so to finish this, or to think of some next steps, is I'm going to distribute this negative 1. Kind of got to watch out for that, a little tricky sometimes. That leaves me an x here, and that would be a negative 3x and a minus 4. All right, we're going to solve now. I'll put a little line to divide the sides because it's a little bit tricky sometimes. These two are going to combine to get a negative 2x minus 4. We still have the x plus 1 over here. All right, so now we got a x to one side, so I'm going to add the 2x over here, leaving me a 3x plus 1 equaling the negative 4 on this side. I'm going to minus the 1 off. That would leave me with 3x equals negative 5. And then I'm going to divide both sides by 3, leaving me x equals negative 5/3. So that would be my answer. But we have to think for a second. Will this cause the denominator, any of these denominators, equal 0? Well, what would make this a 0 is 0, and that's not 0. What would make this equal to 0? Well, what would that be? What would make 3x plus 4 equaling 0? Well, if we minus 4 to both sides, okay, and then we divide by 3, that would mean that x cannot equal negative 4/3. That's a restriction. But this isn't, it's close, but it's not the same, so we are okay because this is close to that, but it's not the restriction. Again, x cannot equal 0, x cannot equal this one's the same, and this is 0 again. So my restrictions are x equals this, and x also cannot equal 0. And my answer is neither of those, so this is my answer.